of this three-dimensional object. But do you think that x-axis and the y-axis, do you think they pass the center of gravity? In this case, of course not, because the center of gravity is at 1/3. So the center of gravity is right here. Therefore, the axis passing through the center of gravity is actually this one here. So we call this one y prime, and this one x prime. Would you agree? So the actual center of gravity, the problem asks you to find out the maximum of inertia with respect to the x and y axis, but they are not x prime and y prime, which pass through the center of gravity. Therefore, this is similar to what we use in mass moment of inertia. Now we want to calculate products of inertia. So there's always one value at the center of gravity. And so what's this principle? What's this theory? This is what we call parallel axis theory. But in this case, we call it parallel plane theory because you're not looking at an axis anymore. You're looking at the xy plane. So this is what we call parallel plane theory. So what do you need? Here you have this products of inertia at the center of gravity plus unit mass times what? Times the distance. The distance from the center of gravity to the corresponding axis. And for products of inertia, this is very easy to remember. What you need to do here is unit mass times two distances. Depending on the subscript, if you have x and y, then you need two values. One is called xg, and the other is called yg. So if you are looking at ixy, you have to multiply this with xg, yg. If you have iyz, what do you need? You're going to use d mass times yg and zg. So these two values always are associated with the subscript you use or you consider in calculating the mass product of inertia individually. Now, let's figure out what is the xg, yg here. Well, remember we used the strip that we defined before, and this actually can be determined very quickly. So we say that we're going to cut this strip by looking at this thing here. Like this. Now, what is the center of this unit strip? The center of unit strip, of course, on the z-axis must be what? Half the height. Correct? Because it's uniform. So we know this is h, this is a, and this is a here, respectively. And the center of gravity for this unit strip is right here. So what is the coordinate of this center of gravity? The coordinate of the center of gravity is on the x-axis is what? On x-axis. So you have to read this value projected to the x-axis. Now you know it's going to be at the center. So the length of this is going to be variable x. But what is the coordinate of this g? It's half of the x. Would you agree? Right? Because at the center, so you must be projected to the x-axis and go by to here is half of it. So the first one is half of the x. That's the coordinate of this. Now, what is its coordinate on y-axis? So you project this one down and go to look at here. So what's this value here? Is the y, correct? Because from 0 to here, this is what? This is y. So the y coordinate is just y. What about on the z-axis? It's half h. So there you go. Now, once you identified the coordinates of this center of gravity for the unit volume, and these individual values, because x, y here, they are variables. They will change depending on where you consider the unit strip. Therefore, from here, we actually have found the values of xg, yg, and zg. We have them all. So here, xg is x over 2, YG is just Y, and ZG is H over 2. Now, this is very important. Why? Because once you have this, you can just plug the values into here. And what about the unit mass? Well, you already have the unit mass from step 1, correct? What about this value? The same idea. When you calculate the mass moment of inertia, or in this case, the principle of inertia at the center of gravity, this will always be 0. Because of what? Because of symmetry. Therefore, in calculating products of inertia, you only have to find out this term here. And this is always true. This is always true for products of inertia. But you know that it's not true for mass moment of inertia, because mass moment of inertia at the center of gravity is a 0? No. It's minimum value, right? But it's not 0. So let's try this one out to see what is the product of inertia, Ixy. So dIxy becomes what? Becomes 0 plus xgyg is xg is x over 2. Yg is just y times unit mass. And the unit mass we used before for dx, for Ixx, the unit mass we use here is, we said this is rho times h times a minus y times dy. So this is the dn that we used before. You can double check with step 1, right? So this is the dn. Then what we have to do is basically add these two terms into this integral. So instead of calculating the dn, you calculate the dn, integral of dn times xg and yg. To put xg and yg into this integral, then we will find the values of products of inertia. If you need the product of inertia on the xy plane, you put xg, yg. So here, xy becomes integral. Now, we can take the constants out. And here, what are the constants? You know, rho is constant, h is constant. You can take them out. So this becomes rho times h. They integrate everything from 0 to a. Why is from 0 to a? Because we are using dy. So the value of y is from 0 to a. Now, you have a minus y here, and this represents x. You also have another x here. So what do? So you also replace this x with in terms of y. So x in terms of y is also a minus y. So here we're going to have a minus y squared. Because this is x and this is another x, so we have x squared. Correct? Now, what about this 1/2? We'll take it out. So 1/2 is here, and then you have y times x squared, which is a minus y squared, dy. Right? Now, it is essential for you to compare this expression versus the integral of total mass. The only difference, like I said, is only these two terms, xg and yg. Because this is what we're going to repeat for finding the x, yz and izx. So of course, you know how to carry out this integral, correct? This is a polynomial, so you know how to do it, and I'm not going to bother you with this. So here, Ixy, and the result is going to be 1/12 total mass times a squared. Now, what about Iyz? So this is IXY. What about IYZ? Remember, write down the definition first. IYZ equals to IY prime Z prime. And of course, very soon you're going to realize that this first term is always going to be 0 because of symmetry for products of inertia. So when you do that, and this becomes what? This becomes dm times, you have y and you have z, so you're going to put yg here and zg here. That's pretty systematic, right?